All right, everybody. This is the 3.7 video notes here on graphing absolute value functions. And we're going to do some transformations of those. So let's take a look. So first thing that I kind of want to quickly go over again is just kind of evaluating absolute value functions. So remember, when you're evaluating, you're just plugging in whatever value we're telling you to evaluate for. So I'm just going to take this -2 and plug it in. And so you get the absolute value of -2 minus 3. -2 minus 3 is the absolute value of -5. Now remember, absolute value is just distance away from 0. Okay, so how far is -5 away from 0? This is 5 away, and so we get an answer of 5. Okay. But now look what happens to the next one. If I plug -2 in over here, I get -4 times the absolute value of -2. Remember, in math, and we don't have, when you can't see the operations, it's going to be multiplication. All right, so now the absolute value of -2 is +2. So I have -4 times +2, which is -8. So don't think that just because you see the absolute value sign is always going to be positive, because if you put a negative out in front outside the absolute value, it can make the expression negative. Okay, so we get -8. So that's kind of like a quick little review on those. And so now we kind of want to talk about graphing these things. And so before we even start, I want you to think about what they could look like, right? Because we know that once you start plugging stuff in, for example, on this first problem here, once I took the absolute value of a negative, it became a positive. So I want you to kind of think about what this graph of the parent function, right, f of x equals absolute value of x, is going to look like. All right? And if we plug in some numbers, I'm going to pick a couple negative, a couple positive. So x is -2, -1, 0, 1, and 2. Let's see what happens. Okay, if I plug in -2 into this equation, I get the absolute value of -2, which is +2. Absolute value of -1 is +1. Absolute value of 0 is going to be 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Again, absolute value is distance away from 0. And so now if I graph these on the on our graph over here, I get 0, 0, 1, 1, 2, 2. Those are the positive ones. And on the negative, I get -1, +1. So right here, left 1, up 1. And then -2, +2. And so when you have these absolute value equations, you end up getting this V. It'll look something like this. Okay. And so this is kind of your graph of absolute value function. This is your parent function. And remember, like we said in the last video, now we can just take this parent function, just shift it around and move it and kind of see what happens. Okay. So on the next problem, I'm actually going to pull up Desmo so we can kind of see us stuff moving around a little bit. So here it is. That's the same graph. Y is equal to the absolute value of x. And so now if I put in on the inside of the absolute value, if I put in a term here plus a, add a slider. Now, if we're at 0, where'd it go? Okay, so this is your parent function. Okay. Now, when you have a plus a number, look what happens to the graph. If I move this, if I make this positive, our graph is shifting to the left. Can everyone see that? So again, here's 0. This is our parent function. As I go positive numbers, we're shifting to the left. Okay. And now if I go negative numbers, we end up shifting to the right. And so in the function, we have, let me add y equals. Okay, so the green one here is our parent function. And so in the second problem, we have the absolute value of x plus 1. So maybe make this +1. Okay. And so you see here, the green one is our parent function. The red one is our new one. We see that we've taken the graph and just shifted everything over 1 unit. And if you wanted to make a table, you could do that, right? But the reason why we like learning about these transformations is it makes it a lot easier, because then we don't have to worry about making a table. We can just shift this parent function around. Okay, so that's that second problem. So now let me reset this back to 0. So now we should be back to our parent function. And now what happens if we add a number on the outside. So like problem 2 at the bottom there, okay? Where we have the absolute value of x plus 2. Okay, so now look what happens if I move this number on the outside, this b. Okay, so if I move this around, if it's positive, the graph starts to shift up. Okay, and you get higher and higher, right? Start getting like a 0, so that's our parent function. And if I go negative, we move down. And so in that second problem, right, what have we done? We've just shifted the whole entire graph up 2 because we have that plus 2 on the outside. Flipping it over on the back, let me now add in a term in front. Okay, and so again, now, so now I've got this multiplication term in front, so I have some number c times this whole thing, right? Remember that when you have this term in front, it starts at 1 because if it was 0, then 0 times, for example, if I do 0, it's just going to go away. Okay, because 0 times anything is going to be, it's not going to do anything. So we start at 1, so that's your parent function. And first thing, let's just look at what happens as you get bigger than 1, right? So look what happens here. Our graph gets skinnier and skinnier. So this is, again, what we call a vertical stretch. Okay, and so the steeper this, or the bigger this number becomes, steeper and steeper it gets. If we get to 10, see how steep that is. And if I do a fraction, so let's say like 1/2, right, or even if starting at 0.9, see this thing starts to flatten out a little bit, and so this is called a vertical shrink. Okay, so if I do a half, you see right there, right, it's a lot flatter. And then what happens when the number becomes negative? It just flips the graph over. So if I have -1, it's just going to be a reflection over the x-axis of your original parent function. Okay, and then the steeper this becomes, right, so on and so forth. And so that kind of talks about the next 2 graphs. We have a -2, so the negative flipped it over the x-axis, and then the 2 made a stretch. And the last one there, the 0.5x, 0.5 times the absolute value of x, we kind of just looked at that, right? It was a vertical shrink. So again, we like using these translations because it makes it a lot easier just to graph it instead of making tables every time. Okay, so we can kind of summarize this whole thing here. Okay, so what happens when you have this h term on the inside? Okay, this is going to be your shift left to right. Okay, and then here I'm going to put in if the number is positive, you shift left. If negative, shift right. When you have this plus k term on the outside, this shifts the graph up and down. If a is bigger than 1, this is a vertical stretch. And if a is less than 1, this is a vertical shrink. And last but not least, if it's negative, it's going to flip over the x-axis. So again, instead of looking at individual tables, we can just use these transformations to then just graph a lot faster, which is pretty nice. So that's kind of it for this video, guys. It's a pretty short one, just looking at transformations again. As always, if you have questions, please let us know. But if not, have a great rest of your day.